right, Squirrel, it's time. Are you ready? You gonna help me? No, do not attack the mouse. Okay. Squirrel is refusing to play unless you attack the mouse? What? Makes no sense. Goofball. Okay, so today what we are going to do is we are going to take a look at the first half of details of graphs. So I'm going to go over these 6 and go on to maybe some of these, depending on if Squirrel will help me. And then I will leave those because those are pretty tricky for our next video. So, starting back up here, we've talked about the toy rocket and how from left to right it goes from 0 to 4. That is what the domain means, Squirrely. Yeah, that's what the domain means. So, domain is left to right, which means we're going to do a domain here again. Left to right. So the farthest left it goes is 1, 2, 3, 4, -4. It goes all the way to infinity. So x has to be bigger than -4. So that means we're not looking at A or B. If we take a look at that dot, it is a filled in dot. Filled in dots mean there has to be a line underneath. Okay, the range of the function. This got fun. The range of the function. So in order to do the range of the function, that would be bottom to top. Let's pull out our calculators. All right, so we type this into the calculator, we hit enter, and we get something that looks like this. Let's shift it up a little bit, and it looks like it goes down to here, which I'm guessing is -9. It's certainly not -1, so it's not going to be -1. Now, is my loop-the-loop bigger than -9 or smaller than -9? Yeah, it's got to be bigger than -9 because it starts down here at -9 and then it goes all the way to infinity. So it's going to be greater than or equal to -9. Good job, Squirrel. All right, next one. Range of the function as defined below. Okay, gotta type in this one now. So we go up here and we start with 5, and then we need to get that x in the exponent. So we do caret x. Enter. This is our coronavirus, our zombie, where we start nice and chill, and then we go exploding upwards. Yeah, it's the scary one. It's okay, Squirrel. You can't get corona from the graph of corona. It's okay. I know. You're worried. It's okay. Notice when we go the other way, it's getting really, really close to 0. Yeah, that's what it's asking for. It's asking for the range. So it's asking from the bottom all the way to the top. Well, top is going to infinity, right? So it's not going to be less than 0. It's not going to be less than or equal to 0. So it's either got to be greater than 0 or greater than or equal to 0. Can it touch 0, Squirrel? That's the big question. No, it can't. Good job. It cannot touch 0. Remember how we talked about half-life and how there's always going to be a little piece there? When we've got a big paper and we chop it into half. Oh, squirrel, calm down. We chop it into half and this half disappears, then we chop it into another half and this half disappears. Chop it into another half, this half disappears. We're always going to have a little piece left. Yeah, soon it's going to be so small you can't even notice it, but it's going to be there. So it's not going to be equal to 0 because it never actually touches 0. I know that one was tricky, wasn't it, Squirrely? Okay, let's take a look at number 5. Which function has the greatest y-intercept? Okay, Y-intercept means where it crosses the y-axis. So let's take a look at the first one. The first one, f of x equals 3x. Yes, our y-intercept is going to be 0. Good job, squirrel. Why is our y-intercept going to be 0? Yeah, because there's nothing out there. There is no, this should be y equals mx plus b, but there is no b. So because there's no b, it must equal 0. And then up 3 over 1. So this, yeah, that's not going to have the biggest y-intercept. We can automatically get rid of that guy. It's not going to be this one because 0 is not going to work. What about the next one? Well, the next one isn't put in terms of y equals mx plus b, so we're going to have to type that into our calculators. Yes, I could solve it if I wanted to. Do you want to solve it, Squirrely? Whoa. You want to hug? Okay, I'll hug you. So we got 2x plus 3y's equals 12. And this is going to be a problem. I've seen a lot of people try and do this. Be very careful. You already have an equal sign. In order to type it in like this, so that you can type in the equal sign, you need a relationship. Like Squirrel and I, we have a great relationship, right, Squirrel? Yeah, we do. Don't even pretend we don't. Okay, so 2x plus 3y equals 12. Enter. Okay, let's get some menu 2, 6 in there. And if we look, it is all the way up at 4. So it's crossing up here at 4 and then going down 2 over 3, down 2 over 3, down 2 over 3. So it's going to look like this. Yeah, that's also not going to have the biggest y-intercept. So we've tried A and we've tried B. Neither have the biggest y-intercept because D is still winning. D is the black line. D is still winning. Yeah. Okay. A line that has a slope of 2 that passes through 1, negative 4. So, what are you doing? Are you getting tangled up in the wires now? You have to be more careful, Squirrely. All right, 1, negative 4. 1, negative 4 is down there with a slope of 2. That makes it like this. Okay, that's definitely not going to have the biggest y-intercept. Not even close. That's way down here. That's going to have a negative y-intercept. That means that D must have the highest y-intercept because that guy is all the way up here. Yep, they graphed D for us. We don't have to graph D, Squirrely. All right, number 6. Which function has zeros of negative 4 and 2? Zeros of negative 4 and 2. Yeah, let's take a look. What do zeros mean, Squirrel? Do you remember what zeros mean? It's on the page. Means what? Don't know? Don't remember? It means x-intercepts. It's where it crosses the x-axis. So this guy crosses the x-axis at negative 2 and positive 4. So this one's not going to be it. And D crosses at negative 4 and positive 2. Hey, look at that. That's what we wanted. We could also then plug these in and figure out where those cross. In order to figure out where those have y-intercepts, we'd have to go back to our graph and actually do that on the graph. And we can do that. We'll do the first one of those. No, Squirrel, we don't have to. It's just if we want to. So it would be y equals... Yeah, it's because I want to. Hold up. Now you're just being silly. I want this guy. And we're going to delete. And we're going to say x squared plus 7x. Yes, minus 8. Don't worry, I won't forget it. Minus 8. Enter. And that guy, oh, that looks really weird. Let's take a look at that. Sometimes your zoom will get all out of whack. That's okay. Let's just go back to zoom standard. There we go. This one is crossing at 7 and 1. I'm sorry, negative 8 and 1. Do we want negative 8 and 1? Negative 8 and 1 are nowhere near what we want, is it, squirrel? No, we want negative 4 and 2. At least it has a big negative and smells positive. Okay, so that's how we get number 6. We just did A, and of course we could do B the same way that we did A, just to check to make sure that one's not right. Next one. The height h in feet of an object dropped from the top of a building after t seconds is given by this. How many feet did the object fall between 1 and 2 seconds after it was dropped? Determine algebraically how many seconds it will take for the object to reach the ground. Okay. Yes, we graphed this. Good job, squirrel. Automatically, we're going to graph it. No, we're not going to attack the headset. We are going to graph it, squirrel. Yes, we are. We're going to graph it. I know we're going to graph it. The graphing calculator is very important here. No, it's okay if they don't have a graphing calculator. They can just watch me do it. Yeah, it's okay. They can just watch me do it. It's not that bad. They can just follow along. Okay. And this one is clearly going to be bigger. Let's go all the way to 144 and see if that works. And there it is. Okay. Whoa. Control Z. There we go. That's more what I wanted. All right. So let's take a look at what's happening here. We want to figure out how many feet did the object fall between 1 and 2 seconds. All right, at 1 second, it looks to be about there-ish. And at 2 seconds, it's down to around there. How are we going to figure this out? Well, we could start plugging in numbers, or we could make the calculator do it. If you go to menu, go to table, split screen table. At 1, we're at 128, and at 2, we are at 80. Good job. So really what we need to do is we need to figure out 128 minus 80. 128 minus 80. We've got an 8 there. And then 12 minus 8, do you know, Squirrely? Really? You don't know 12 minus 8? That's really important. 48. So it's going to drop 48 feet. 48 feet. Determine algebraically how many seconds it will take to reach the ground. I don't like algebraically. I'm just going to go back here, menu, table, remove the table, and I'm going to take a look at the 0. Where does it actually hit 0? It hit 0 at 3 seconds. And we're done with number 7. Okay, let's take a look at number 8. Alex launched a ball into the air. The height of the ball can be represented in this. Yes, it looks exactly the same, doesn't it, squirrel? Graph the equation from t equals 0 to t equals 5. State the coordinates of the vertex. Ooh, vertex. We haven't done vertex in a while. What does vertex mean? And explain its meaning in the context of the problem. Yeah, vertex is the highest point or the lowest point. It just depends on what's happening. But you're right, if we're tossing a ball in the air and then it comes back down to the earth, the vertex is going to be that highest point. So let's go back to here and we're going to type this in. Good, delete, delete, delete. And it's going to be negative 8x squared. Not negative 88, but nice try. Yeah, sometimes I type it in wrong. It's okay, squirrel. Stop judging me. Plus 40x plus 5. And yes, I am using x's. That happens sometimes. Okay, if we look, it looks like it's ending at 512. So graph from 0 to 5. I'm not going to do a very accurate graph, but I do want to figure out where that is hitting the highest point because that is part 2. It wants to know about the vertex. So menu, analyze graph, and we're going to find the maximum. So we're going to find the maximum. It's at 2.5 and 55. So if I do 1 here, and then 2 here, and then 3 here, 4 here, and 5 here. So 2.5, that would be here. We are going to go all the way up to 55. So 10, 20, 30, 40, 55. Yeah, it's going to look like that, squirrel. And I'm just going to do a nice, beautiful parabola. It looks sort of like this. So I've graphed it. You might want to put arrows on the end, but to be fair, at this point, this is going to be his height, and this is going to be when the ball has reached his height again. The vertex, it asks us to state the coordinates. So this is going to be 2.5 and 55. And then it's going to say explain the meaning. Yeah, explain the meaning. What does 2.5 mean, squirrel? That means seconds. So 2.5 seconds after the ball was thrown. Ah, squirrel, you can't close my window like that. I'm in the middle of doing a problem. It's not very nice. After the ball is thrown, it reaches maximum height of 55 in units? Really? Okay. 55 units. Feel like they were just being lazy at that point. All right, so that's how we do 8. Let's go on to number 9. See what's happening with number 9. I want to do 9 and 10 today. In this function, the minimum value occurs when x is what? Okay, so we have to graph that. Always graph when confused. So we're going to go x minus 2 and parentheses squared plus 4, enter, and it looks like when x equals 2, that's when we're going to get the minimum. And for this guy's an absolute value. Be very careful. We're going to figure out how to get absolute values now. Delete all that. Absolute value is this button right here next to the book. So we're going to do the absolute value of x plus 3. And then we're going to do a minus 2 on the outside. Enter. And oh, this looks very troubling. That is because my window is weird. Let's put it back to standard window. Yeah, sometimes we have to just put it back to standard window because I was fiddling with it. Okay. And this is going to be what, -3? What is the minimum value of the function? Careful. This one's asking when x is, so we need to figure out the x value. This one's asking what the minimum value is, so how far does it go down? Well, the farthest it goes down is -2, right? That sounds like a trick question, isn't it, squirrel? 9 and 10 need to be done together because 9 is asking for the x value, but 10 is asking for the y value. Be very careful because it's very dependent upon how they word the question. Yeah, it's not very nice, is it, squirrel? All right, tune in next time to see me finish up the packet. Make sure that we've got all of those done, and then you're going to take your video. Make sure you send this to me by April 27th. Thank you very much, and have a wonderful day.